So now we do the jumps and branches. I hope what you can see here is that we're now going to be fooling around with the PC logic because they affect the program counter. So I'm going to talk about two separate things. One is changing the program counter, which up to now has just been incrementing by 4. And the other, and this happens for all the jump and branch instructions, we always into the destination register here, into register RC, we're always restoring the address of the instruction following the jump or branch, so the PC plus 4 value. So PC pointed to the address of the jump or branch instruction, and so PC plus 4 will be the address of the instruction following the jump or branch. That value is the value that actually gets routed through the WD cell mux and is written into the RC register. So in jumps and branches, we're going to change the value of the program counter, and at the same time, we're going to remember where the program counter was before we changed it, where the next instruction would have come from had we not changed the program counter. In the case of a jump instruction, we basically take the contents of the RA register, and that simply becomes the new value of the program counter. So whatever was in the RA register, almost always in our programs, is the value in the LP or the XP register, so the linkage pointer. This is how we return from procedure calls. We basically just stuff that value into the program counter, and away we go. The next instruction will now come from wherever some previous branch came from. Okay, and then finally, branches are very much the same in terms of writing PC plus 4 into the register file, but they need to test the value of RA to determine whether you're going to branch or not. And the choices are, if we don't branch, we're just going to load PC with PC plus 4. So that's what happens if we don't take the branch. If we do take the branch, how do we decide if we take the branch or not? Well, what we're going to do is to look at the value of a particular register and see if it's 0 or not. Big NOR 32 on the output of register A from the register file, and we're going to test to see whether it's 0 or not. And if it is, we want to set PC cell, as if we're doing like a BEQ. So if Z is 1, in other words, the contents of RA is 0, that means if we're doing a BEQ, if we're going to branch, if it is 0, we basically look at the Z signal to see, is it 0? So that means Z would be 1. And in that particular case, we would set PC cell to 1. So PC, for branch instructions, PC cell will either be 0 if we're not taking the branch, or 1 if we are. If we do select 1, what is the new value of the PC? Well, we take the old value of the program counter and basically change it by the word offset that's encoded in the literal field. Suffice it to say that this is called a PC relative branch. In other words, some distance from where the PC currently is where the destination is. And that distance, either earlier in the program with a negative offset or farther in the program, later in the program with a positive offset, that offset is added to the program counter and becomes the new program counter.